All right, today we're going to talk about vector operations. And I don't mean surgery on vectors. Vector operations? No? We need an applause sign, so you. See, I'm already trying to improve my mood.
I liked it.
Yeah, but you didn't laugh.
It was a delayed laugh, but
I
it
was
was
laughing
nice.
internally. No one else had that.
Okay, Israel.
All right, here we go. Operations with vectors. So last time we worked with vectors, we worked with them graphically. We had no numbers. We just moved them around everywhere, and this time we're going to talk about them with numbers. And just reviewing what we learned last time, a vector is a directed line segment and can be put anywhere on this XY plane here. But I want to talk about how we can write a vector in component form. So I'm going to call this vector U. And component form is nothing more than the pathway from the tail to the tip of the vector. Okay, so, and we use these angle brackets. Okay, now the path that we're going to take from the tail to the tip of the vector is going to be horizontal and vertical only. Okay, so how do I get over from the tail of this vector to the tip of this vector? Well, ends at 6, but starts at 1, so it's going to be 5 to the right and 3 up. So the component form of this vector is going to be 5, 3, because no matter where it is in space, if you start at the tail and you move 5 to the right and up 3, you will end at its tip. So the roadmap. And it's horizontal and vertical, which implies that this is perpendicular, which is really nice. All right, now we said vectors were directed line segments, which means this doesn't go on forever and it has a fixed length. We call that fixed length a magnitude, okay? So the magnitude we write with U in absolute value bars. An absolute value distinguished from what we did with absolute value bars in the past, so that's the distance to 0. It's a positive number always. And so we're going to make this the magnitude of the vector. Now, how do I find the length of this vector? Yeah, we could go to trig or Pythagoras. Absolutely, we can find Pythagoras. So we can say its magnitude is going to be the square root of 5 squared, yep, plus 3 squared. And so this vector's magnitude will be equal to the square root of 25 plus 9, which is 34, right? So it'll be root 34. So this is the vector's magnitude is 34 units. So now we found its magnitude. Now how do we figure out what its direction is? Now the direction is going to be this angle here. So how do I find that angle? Measure from the horizontal. Tangent, yes, absolutely, I like it. So we say that the direction is going to be theta equals inverse tangent of 3 over 5, because that's the opposite over the adjacent. And if we type that in the calculator in degree mode, we're going to get somebody. Well, let's talk in degrees today.
30.96.
30.96 degrees.
1 radian.
Okay? So now we have found its magnitude and its direction. And what is component form again? It's nothing more than the roadmap from the tail to the tip, horizontally and then vertically. Okay? That's kind of what the things we're going to do today. Now, let's talk about vectors in standard position. Standard position, where have we heard that before? Angles in standard position. On the XY plane, when an angle is in standard position, what was at the origin? You're right. The vertex of the angle was at the origin, and the initial side was on the positive x-axis. Well, a vector in standard position, I feel bad because you guys can't do this, but I can because I have a smartboard, is when the tail is on the origin. So vector in standard position. The tail is on the origin. Okay, now what would the component form be of this vector? Let me get rid of this. Well, that's going to be 1, 2, 3, 4, 5, 6, 7, 8 in the horizontal direction, and then 1, 2, 3, 4, 5, 6, 7, 8 in the vertical direction. So I can say vector u is equal to, in component form, 8 to the right and then 8 up. What would this vector's magnitude be? Well, we're going to show the absolute value bars, and that would be the square root of 64 plus 64, right? Which is, whoops, I put 16. 64 plus 64, which is root 128, which happens to be 64 times 2, which is 8 root 2. Yep. What is its direction? Which is its angle with the horizontal?
Inverse tangent.
Which is? That's right, inverse tangent of 1. Because this is 8 over 8, which is inverse tangent of 1. And because it's in the first quadrant, we know that theta is going to be 45 degrees. Everybody got that? All right, so we're going to move vector v into standard position. Here it is, vector v. I'm going to put it in standard position.
How long is that?
It's 3 to the right and then 3 down, yes. So vector v in component form is going to be 3 to the right and then 3 down. What is its magnitude going to be? It's going to be the square root of 9 plus 9, which is the square root of 18, which happens to be 3 root 2. And what is its direction?
South.
Okay, so we could say that theta is negative 45 degrees, or if we want to remain positive, that's right, 315. Now, do we remember how we were going to add these vectors?
Tip to tail.
Tip to tail, yes. right? So which way would you like to go? Would you like to move V? Or would you like to?
Yeah, we'll move V.
We'll move you.
No,
V.
we can't move her. She's doing the thing.
We could move both of them.
No,
Let's move
just
Wait,
V.
why are we moving them?
Why are we moving them?
To
We have
add
to
them.
Oh,
combine.
to add
Add
them. Don't you? I thought you.
Oh my.
Oh, we had to put it to tips to tails. Okay.
Right,
I was
right,
Like, I was
on
like,
that-
can't we just build a little thing right there?
Now, do they have to be in standard position to add
No.
them? No, they don't. Do they? And now if I add V, it's going to be up here. So we're going to be a little bit off the screen, aren't we? Oop.
You know it's 3, so
Yes.
this is gonna be 11.
Wow.
Okay, and so then this would be the resultant.
Can you move the other V? It's kind of freaky.
It's at 11.5.
Never mind, it's fine.
Are they equivalent? Why don't you don't like the visual of that being there?
Because then I see it like this.
Is that would it be facing the other way? Isn't it U plus B?
I'm doing U plus V.
Oh.
So U plus V is going to equal, now, if we were going to do the component parts here, I'm adding 8, 8, 2, 3,
3.
negative 3, right? So I'm saying I'm going to start at 8, 8, and I'm going to move where? To the right, 3, and then down 3. So that means I'm going to take 8, add 3 to it, which gives me 11, and then I'm going to take the other 8 and subtract. So it's going to be 8 plus 3, comma, 8 minus 3. And so the new resultant should be, in component form, 11, comma, 5. And does that make sense? Let's see. Does it look like this? This is a 10 by 10. So this looks like it's 11, 1, 2, 3, 4, 5. It does, doesn't it? Does it have a different direction and a different magnitude?
Yes.
So let's find that. So what would the magnitude be of U plus V? 121 plus 25? 1.
No, 46.
$146? Do we have any perfect squares in there?
No.
146 divided by 4 won't go in.
It's 2 and 73.
Nice. Yeah. Okay, so we're stuck with that. And what would its direction be? Theta equals inverse tangent of? Now this resultant has its own opposite and its adjacent, right? Which means it's y over its x. So it's going to be 5 over 11. Because this is the opposite and this is the adjacent, isn't it? How convenient is that? 5 over 11? So I don't know what that is off the top of my head. Does that look reasonable based on our resultant, our red resultant? Yes.
Can you go back over how the opposite and the adjacent are
Sure.
divided?
Okay, so up here, if I want to find this angle here, this right here in component form, this is the
Oh, that's
opposite, right, which is 5,
mhm.
and the adjacent is, 11, I'm sorry, it's 11.
Oh, okay. Nice.
Does that make sense?
Yes.
I think it's pretty cool that you have an opposite and adjacent already built in vector component form. All right. That's pretty cool. What's standard form again?
A plus B.
Got 10 minutes. So the tail has to be at the origin. And what is component form. Basically,
The X and Y.
it's an X and a Y, but it's a horizontal and the vertical direction, but it's basically a road match from the
Tail to tip.
tail to the tip. Yes, that's what I'm getting at. I don't want vectors to be intimidating, so I use that kind of fun language. Road map. All right, so sometimes they don't give us the vector in vector form, but they give us the coordinates for the tail and the tip. Okay, so this says graph the vector in standard position and find its magnitude. A is the initial point, which means it's the tail, and B is the terminal point, which means it's the tip. So this is the tail, and this is the tip. And then I'm going to graph the vector. So we're going to go to point 3, 2, put a point, that's A. And then we're going to go to point 1, negative 3, put a point, and there is B. And this is my vector, AB. All right, so if I want to know what AB is in a component form, the horizontal distance now is as I'm going to go from the tail, I have to go which direction?
Left.
To the left, so I'm going to go 1, 2, 3, 4 to the left. So that means
Wouldn't you go down
next.
first?
No, you always go horizontal first. And then -5. Good. Now, let's put it in standard form. So what do I have to do to put it in standard form? I'm sorry, what? So I'm going to take this now and do what with it? Put it here. Let me get rid of this B here. Now my pen is very thick here, so it's not necessarily precise. But what I would love for you to notice is, now when it's in standard form, what point is this vector pointing to?
-4, -5.
That's right. It's pointing to this point right here, which is -4, -5. So this is it's like a position vector because it's pointing to the position -4, -5, which happens to be the same as its component parts. Does that make sense? Now, algebraically, how can I do this if I'm given 2 points?
Distance formula.
We could do the distance formula.
Go. Just start at 0, 0, and subtract 4.
I'm saying directly from here. Wouldn't it be nice if we didn't have to graph it to find the component parts? Because what did we do? We looked at the graph and we moved left 4 down 5, right? Wouldn't it be nice if we could just go immediately to component form if we were given the points? So if I'm starting here, I would say -1 -3. Because we're starting at -1. And then we're kind of going backwards, aren't we? And then we can say -3 -2. And then what happens when we do that? So we say this is -4, -5. They call this the tip minus tail method. To find a vector in component form.
I was just making sure it always has to be the tip.
It's always the tip minus the tail. Yep. So that's an easy way to do it, isn't it? Without having to graph it. All right, so what's the magnitude of this thing?
The absolute value.
Mhm.
equal the square root of 4 squared times
16 plus
25.
25, which is root
41.
41. Good. And its angle, its direction is going to be inverse tangent of -5 over -4. But we have to watch it here because what quadrant is this vector in? It's in quadrant 3, so I need to know what alpha is, don't I? So if it's not a quadrant 1 situation, we have to find alpha first. So alpha is going to be the inverse tangent of the positive, which is 5 over 4. Somebody do that? Okay, 51.34. If that's alpha, what is theta going to be then?
231.
It's going to be 180 plus 51?
Yeah. 260 minus
2. Everybody understand where I got that from? Because it's measured from the horizontal? So it will be 180 plus alpha. Okay, let's do another one.
Yes.
We got one more that we can do before lunch bell here. This is going to be the
Opposite.
tail, and this is the tip. So let's use the algebra technique we have. AB is going to be 3 minus a minus 1, which is 3 plus 1, yes. And then 2 minus a minus 3. So this is going to be 4, 5. So do we know the magnitude of this one already? Yep, what is it going to be?
The square root of 41.
It's okay, so it has the same magnitude, but what about its direction?
It's the opposite
It's
way.
the opposite direction. So let's plot the points now. So we get -1, 3, -3, and then 3, 2. And so now we're going this direction instead of the other direction. I'm going to copy it and paste it and put it in standard position. And what point is it pointing at?
4, 5.
4, 5, which is nice. And what is its angle? It's theta, its direction.
51.3.
That's right. And that's because it's a quadrant 1 situation. It'd be 5 over 4, which is equal to 51.34 degrees, okay? Not too bad?
not too bad.
I've got 2 minutes here. Should I pause now?
No, let's keep going.
Let's pause it.
Let's pause.
Speed run.
I'm pulling out the remote, Wes.
So, me too.
I know.
Oh. I see why we have recording.
What do you mean?
Oh, there we go.
All right. Let's try this one.
0 minus.
Did I get somebody that wants to come up and try this one?
Come in, Jack. Tag team it.
Remember, we're live.
You're right.
And so we're gonna do it algebraically.
I need more space.
Okay. So what's this first number gonna be?
What we're doing. We're doing
0 minus 2. Good job. Okay. Let's relax. Let's
Alright, you
draw it first.
You can do this.
You can draw it.
All
You
right,
can-
we're
you
gonna
know,
draw
this-
it.
Believe it or not, this board will allow you to do two things at one time. So
Alright,
you
cool.
can be writing while you're doing it.
Cool.
Now, he's trying to copy that, so you can't do that at the same time. Let him paste it. Paste is the top one. There you go.
You good?
Hey, good.
Nice. Don't worry about that. Don't worry about that.
Cool.
It's just restarting. It's fine.
Do you mess it up?
Nope, you're fine. You're all good.
I'm sorry.
No, you're fine. It's all good. Here we go.
So you
Yeah,
I know.
Data.
Yes, you do.
learning's going on, and that's what's important.
You're back here.
You guys are doing it?
Oh, I think that hasn't dried yet.
Yeah. Mr. Herbs could have a calculator.
Jason.
It's gonna be -2 on the bottom, right? But you have to find alpha, right? Because it's in a quadrant
2.
2.
You anybody give me this number?
He's being a teacher here. I like it.
Well, stop looking at me. Give me the answer.
That's
Yeah.
negative 68. That's not.
I'm in read.
Here.
You gotta take alpha first.
Oh, alpha. Alpha
It's
is
gonna be inverse tan of 5/2, the positive, right?
yeah.
You had it. You had the answer.
I know.
Alpha's equal.
68.20.
Thank you, Ricky.
68.20.
So what are we gonna do with that?
You're gonna do 1/8. Sorry. I know it.
90 plus.
No.
No.
180 minus.
Oh.
180 minus.
Wesley. I appreciate you trying that.
Thank you.
I can't draw it.
Which is
That's cool. Just let it go.
Degrees, can we put a degree mark?
You're- No, he already has a degree.
Okay. All right, so, not difficult to do. Yay, thanks. Congratulations,
You're welcome.
gentlemen.
you proved it wasn't difficult.
All right. Another one? All right, come on, Will.
Muy bienvenido.
You wanna work with him? Is that what you're?
Sure, why not?
It's gonna be tough to
Sorry.
show that.
What?
Yo, can you finish the B? The letter B.
Oh, now,
Don't have to spew fine. Sorry about that. How do you feel this way?
The last one was fine.
Come on, buddy. That was Jack.
Good job, man.
hey, you want
How
the
do you do
pointer?
that? How do you do the?
The copy and thing, you press, yeah, press the pointer. Well, you just have to click on the arrow. Click off of here. Here we go. Whoop, you got it. It's gonna have the B with it, I mean the big A with it.
How do you hold it?
Yeah. We'll be able to get rid of the big A.
It's a nice A.
Right. I think we can, hold on. I think we can do this even. Oh, that's gonna change its magnitude, isn't it? We don't wanna do that.
Can't do that. Is it? Alright. Oh, that precision.
I don't know if it's precise.
Whoa.
There you go. You're all set.
Should I do it?
Yeah, so what is the square root of 50?
Let's see, is that, oh, 5 or 2.
Good. Okay, remember my board is being a little strange down there, so we gotta scroll up. Oh,
Yeah, but then you have to like switch it, and it's like, it's seconds off the time. And then, oh yeah, there's the alpha, because it's, oh wait, no.
Well, is theta equal to
theta,
alpha
theta is
this
equal to
time?
alpha, because this is quadrant. So, theta equals tan inverse of 1.
okay.
And then that's gonna be
It's someone,
8.13.
8.13. Appreciate it.
nice.
beautiful.
I assume everybody's able to do that? And what point is this pointing at, as Ricky has pointed out here? 7-1. When it's in standard position, it's gonna point to the position 7-1, which is like it's component form. Okay, so equivalent vectors are vectors that have the same magnitude and direction. And we're going to check out to see if the vector AB is going to be equivalent to any of these. The vector that passes through these 2 points, okay? And the first one is always going to be the tail here, and then the tip. So what is vector AB in component form?
3.1.
3-1. Everybody agree? We're going to go 4 minus 1 is 3, and 2 minus 1 is 1. What is its magnitude then? It's going to be the square root of 9 plus 1 is root 10. So we're going to see if we can find any vectors here that are equivalent. So we need vector CD.
No.
Well, what is it in component form? We're going to go 2 minus a minus 2. 4, comma 1. Is that going to have the same magnitude? No, and certainly not the same direction. So this one is not equivalent. All right, what about vector EF?
Possible.
It's going to be 3, because it's negative 4 minus a minus 7. And then negative 2. What about this one? Yes, this is going to be equivalent because its magnitude will be identical.
So you don't have to find the direction.
Well, okay, so what would the direction be?
It's the same.
It's the same vector, right? So,
Yeah. If you have your.
but let's find it. Let's figure out inverse tan of 1 over 3. And remembering that this is going to be if I put it in standard position, it's going to be a first quadrant vector. So then this is equal to alpha, isn't it? So what is theta? Help me here. I don't know that one in my head.
18.43.
18.43 degrees. And we didn't find the direction of this, but it will be the same, right? So let's ask that question. Do we need to, if it's the exact same horizontal component and vertical component, is that going to be equivalent? Yes, because it's going to generate the same magnitude and will generate the same direction. Okay, let's try GH. It's going to be 1 minus 4, negative 3, negative 1. So, is that the same direction?
No.
No, it's the opposite direction, but is its magnitude the same?
Yes.
Yes, however, that means it's not equivalent. And I should say that this one is equivalent. I should write that down. This one is not equivalent here. All right, what about my favorite vector?
JK.
JK.
6, 2.
So, could I factor a 2 out of there?
Yes.
I could say that this is 2 times 3, 1. But that's not equivalent, is it?
No.
This one is a scalar multiple of AB. Does it have the same direction?
Yes.
Yes.
It does. This one is a scalar multiple of AB, but has a different direction. What is the scalar here? -1. Scalar here is 2.
You can scale it multiples.
Pardon me?
You can scale it multiples instead of magnitude.
If they're the same direction, it'd be the same.
Right, but this is the opposite direction. So it's going to be 180 plus its angle.
Well, I'm asking is like, so you can scale or multiply magnitude, right? You can do the same thing with direction.
I guess so, yeah.
But it's like not practical.
With vectors, I don't see that very often. Unless we're going to add them.
Looking at how cute this is.
So this is not what?
Equivalent.
Equivalent. What is the magnitude of this vector? JK.
Oh. Just square root of 36 plus.
Root 38.
But, I mean, could we say it's 2 root 10? Is that reasonable?
You can say that.
Is that?
Yeah. And its direction is the same. Do I need to show you that it is the same, or do you
No,
believe
we
me?
got it. We don't believe you.
Okay, good. All right, next. We have to talk about something called a unit vector. And where have we heard that word
Unit
unit before? Unit
Unit
circle.
circle.
Yes, unit circle. Why do we call it a unit circle?
Because it's
All the radius one.
All the radius is 1. And so a unit vector is going to have a magnitude of 1. So that's a big deal. It's going to have a magnitude of 1. Now, how do we create a unit vector in the direction of the following vectors? Okay, so I have this vector 2, 1. There it is. And I want a vector in that same direction that measures 1. What is the magnitude of u?
root 3.
Well, try again.
Root 5.
Root 5. That certainly is not a magnitude of 1. But how can I change that magnitude of root 5 into a 1? Divide by root 5. So I could take my vector, which is u, and I could divide by the magnitude of u, and we'll see if that works. So what is my vector? My vector is 2, 1, and I'm going to divide by root 5, which means it's a scalar multiple of it. So this is going to be 2 over root 5, 1 over root 5 if I distribute the root 5 in. Now, how do I know that's a unit vector? Well, what could we do?
Check it.
We could check it by finding its magnitude, right? We could find the magnitude of u over the magnitude of u. I've got lots of magnitudes going on here, right? So how do I find the magnitude? Well, you just square the x's and square the y's and square root it. So this is going to be the square root of, well, what's the square of 2 over root 5? 4/5 plus the square of 1 over root 5. 1/5. which is equal to the square root of 5/5, which is the square root of 1. Well, guess what? Did we create a unit vector in the direction of u? So how do we do that? What's the process? You find its magnitude, and then you divide by it. So this right here is a unit vector in the same direction of u. Whoops, I don't want to do that one. I'll highlight that one. I'll highlight this one. All right, let's find the unit vector for v. So first thing we have to do is find its magnitude. So what is the magnitude of v?
Root 8.
It's root 8, which is 2 root 2. And to find a unit vector, I take that vector and divide by its magnitude. So I'm going to get 2, 2, and divide by its magnitude, which is 2 root 2. And so I'm going to divide that into each one of them, and I get
1 over root 2.
1 over root 2, 1 over root 2. And we don't have to rationalize here, but if you were to rationalize that, what number is that? Root 2 over 2, root 2 over 2. Where have we seen that before?
45.
The 45-degree angle on the unit circle. So if I were to graph this vector,
Wait, why is that 1 over 2?
here's my vector, right? And so a unit vector in the same direction on the unit circle there is going to have a magnitude of 1. And what is it going to be pointing? Excuse me, what's it going to be pointing to? Well, it's going to be pointing to the point. Root 2 over 2, root 2 over 2, isn't it? But yes, at theta, its direction would be 45 degrees, yes.
If you like get those coordinates, can you go straight to like call me closer to this?
You go straight where?
If you only get like root 2 over 2 as your coordinates for a vector, can you go straight to saying that the theta is going to be? Or
Yes, absolutely. Yes. The direction is that. All right, what about this one? First step is to find its magnitude. So the magnitude of W is going to be the square root of 16 plus 25 is root 41. I'm not writing out how I'm getting it. Are you guys going to remember how to do that? Okay. So the unit vector is going to be W over its magnitude equals, we just go 4, comma, negative 5 with the angle braces over the square root of 41. And we distribute that. I'm going to have to scroll up here because my board's going to get. And what do we get here? We get 4 over root 41. And you guys do not have to rationalize. You can leave it just like this. Okay? Now what would its direction be? How do we find that? Is it going to be the same direction as the original vector? The answer is yes. And if I were to graph this vector, it's going to be over 4 and down 5. So it's going to be over here. It's going to be a fourth quadrant angle. How would I find its theta? To find its alpha first, it's going to be the inverse tangent of 5 over 4. So tell me, is that 51.03?
It wouldn't be negative 5 over 4?
Well,
What didn't
You
think?
gotta find theta first.
alpha. So what is that?
51.34.
That's what I thought. Okay, because I felt like I'd seen it before. So this theta is either going to be negative 51.34, whoops, or what's the fourth quadrant equivalent? 360 minus that.
308.66.
239?
308.
308.
Oh, 308, you're right. I'm in the second quadrant, sorry.
0.66.
308.66 degrees. So either one of these would be fine. So, what is the beauty of having a unit vector? Well, let's say I want to find a vector in the same direction with the magnitude of 10. If I find the unit vector, it's in the same direction already, and it's got a magnitude of 1, so all I have to do is multiply it by 10. Scale it by a factor of 10. Good, I like that language. So for the first one, it would be 10 times u over the magnitude of u, because this is the unit vector, right? No, wait, I'm sorry. We're not going to have the magnitude part. It'll be 10 times u, I've recovered, over its magnitude, but we know this vector, don't we? We said it was
Root 5.
10 times 2 over root 5 and 1 over root 5. And so we can just multiply that 10 in and we get 20 over root 5, 10 over root 5. And this will have a magnitude of 10, but it'll be in the same direction as u. What about the vector for v, if I wanted it with a magnitude of 10? It would be 10 times v over the magnitude of v, because this is the unit vector. So 10 times 1 over root 2, 1 over root 2 equals 10 over root 2, 10 over root 2. So that would be a vector of magnitude 10 in the direction of b. What about 4w? 10 times, now did we say that was 4 over root 41? Negative 5 over root 41. And so that would be equal to 40 over root 41, comma, negative 50 over root 41. Questions on how to find a unit vector? What do? You take the vector, find its magnitude, and then take your original vector and divide by its magnitude. All right. I'm going to insert a blank page here because I'm going to ask you about another vector. I've got a space on the back of this. There you go. Look at that. On the last page, you got space. Where have you seen that before? If this is in standard position. Yep.
Didn't we see like cosine squared x plus sine squared x?
Right.
It's the X and Y for things on the
X and Y on the unit circle. So this could be a position vector pointing at a point. Right? So let's find the magnitude of this vector. So that would just be the magnitude of cosine theta, comma sine theta. I haven't named this. So how would we find the magnitude of that vector? We would just take, using Pythagoras, right? And do what? Cosine squared theta plus sine squared theta.
Is that the big one?
It is the big one. So this is 1. Are we surprised? No. So this is the position vector pointing at any point on the unit circle that is, caused by the angular rotation of theta. It's pretty cool, yes? What if the radius isn't 1?
Then it's not a unit circle.
You're right, it's not a unit circle, but what vector would that be? Do we remember what the point was when we weren't? Go ahead. Jesus, why don't we consider this one? So what is its magnitude going to be?
R.
So it's interesting, isn't it? So it's almost as if it's the magnitude of your vector times the cosine times the sine. So if I had a vector in standard position, so we could just say here, right, that the magnitude of this, does everybody agree the magnitude would be the length of that vector, which would be? Everybody agree? Would be the radius, wouldn't it? So let's say I had a magnitude, let's say, or a vector velocity here, or a plane or something was traveling on this route at whatever this angle is. You want to give me an angle for that? What angle would that be?
106.
106 degrees. And how fast could a plane be flying?
350 miles an hour.
Okay,
It doesn't go fast.
faster than that? Well, what would you like if it's not 300?
600.
7 million.
No, 600 miles per hour. That sounds a little bit better. Okay, 600 miles per hour. If I wanted that vector in component form, that's not on a unit circle, but could you see that it's pointing at something that might be considered a circle? And what would its radius be? 600. And so this in vector form would be 600 times the cosine of 106 degrees, comma, sine of, I'm sorry, 600, right? I followed you. 600 times the sine of 106 degrees. Are we following? Fascinating? Interesting? Yes.
Would that be the negative cosine? Because it's a quadrant too.
Well, if you type in 106 in your calculator, do the cosine of 106 in your calculator. That's a great question. What kind of number do you get? In negative. So if you did cosine of alpha, it would be a positive number because alpha is a positive first quadrant angle, and you'd have to make it negative because it's in the second quadrant. But if you are using the angle itself, then you don't. The angle itself will take care of the negative. Okay. So what did you get when you did cosine of 106? Oh. What is it again? Can you multiply that times 600 and see what you get? Comma, 600 times the sine of 106.
576.76.
Point.
76.
So the component parts, or the component parts for the airplane velocity is going to be this. Because I went over left 165.38 and I went up 576.6. Interesting. I'm kind of foreshadowing what our applications are going to be, okay? All right, moving right along. Now, I do this for several reasons because let's choose some angles that are different because we already did these. Okay? All right. So, Jack, give me an angle. I mean, a vector. Doesn't have to be in any specific quadrant.
-3, 2.
Okay, -3, 2. Good. Okay. And then How about Alex, you give me one.
5, negative 4.
All right, Miss Olivia, I hate to pick on you.
-1.
How can we, give me one in quadrant 3.
-2, -1.
-2, -1, okay? Because I want us to practice using alpha. All right, so if I were to graph this U, it would be -3 up 2. So this is a what quadrant? 2. So right away, I know I'd have to find alpha first, correct? What would be a first quadrant angle? It's if both component parts are positive. So if this is negative and this is positive, you know that you're going to have a quadrant 2 situation, so you're going to have to use alpha. So we're going to go alpha equals the inverse tan of the positive, which will be 2/3. So alpha is
33.69.
33.69 degrees. And so then what would the direction be here?
180 minus that,
Mm-hmm.
which is 146.31.
Does everybody see that that looks like that vector is certainly having that direction? All right, what about this one here? This one, what quadrant this one would be if it was in standard position? Quadrant 4. So I know that I'm going to have to find alpha here, so this would be inverse tangent of 4/5. It's always the y over the x. So what is alpha in this case?
38.66.
38.66 degrees. And since that's a fourth quadrant angle, we can have two representations, right? We can have a positive, and the negative could be negative 38.66. What would the positive one be?
321.
321.34 degrees. Good. Okay, now we have a quadrant 3 angles. We have to find alpha, which will be inverse tan of 1/2. So alpha is in degrees
26.57.
26.57. Now if it's third quadrant, it's going to be
180 plus
180 plus that, which is
206.57.
2 what?
206.57.
Yeah, okay, sorry. Okay, so if your angle is not in the first quadrant, you can't find theta right away. You have to find alpha first, okay? That was the whole purpose of this page. All right. So now let's put it all together. We're going to find the component form. This is a separate sheet all by itself. All right, the singular page. The one I didn't get a chance to go over yesterday. All right, so I'm going to put this vector in component form. So, yeah, but I want to think about it just a little bit. So, do you see how this is a right triangle here? And so this component here is going to be 14 times, yes. So vector V in component form is going to be its magnitude, which is 14 cosine of 55 degrees, comma, 14 sine of 55 degrees. So somebody's going to have to help me with that.
That's 8.03, 11.47.
Now, looking at the vector, does it make sense that the path from the tail to the tip would be about 8 something and up 11 maybe? Okay. So the 14 is its magnitude and its direction is 55. So the formula is kind of this. The magnitude of your vector times the cosine of your angle, right? The component form is going to be the magnitude of your vector times the sine of your angle. All right, what about this one? We'll call this one V1 and the second one we'll call V2. In component form, how would we write that?
33 cosine.
Good. 33 times the cosine of 136. And then 33 times the sine of 136. Negative 23.74, and then
22.
okay. Now, so far, all we've done is graphically add our vectors, right? And how did we do that? We took the tail of one of them and put it where?
The tip of the other one.
That's right. So I'm just gonna do my little snapshot here and grab vector 2. Is that okay? And then we're gonna add vector 2. I'm gonna paste. And I want to make it the same magnitude because sadly it doesn't do that when I'm. Does that look reasonable? No. Any closer?
Oh.
Is that close enough? That's close enough, right?
Yeah.
Okay, so if I'm going to add this, I'm going to take this and do what with it? Put the
Tail.
tail. There it is. And then what do we do?
Find the result.
Find the result. And how do I do that? You're right.
You.
Connect the tail of the first one to the tip of the second one. There it is. This would be the resultant. That would be V1 plus V2. Do you agree with that, the red one? Now, so what does it look like I did? I started, my path was, I went to the right 8.03, I went up 11.04, and then what did I do? I went left 23.74, and then I went up. Okay, so if I were going to write an expression for V1 plus V2, what did we do to the x components? We
Added them.
added them, didn't we? So this is going to be 8.03 plus a negative 23.47, comma, 11.47 plus 22.92. So all we have to do to find the resultant, if we're in component form, is add the x coordinates and the x components and the y components. And what do we get here?
15.71.
15.71, comma, that's negative, right?
Yes. Sorry.
Negative, sorry.
And 34.39.
30, negative 15 what?
Negative 15.44.
4.
No, I did it exactly.
I got 7.
I did it exactly.
You did it exactly?
Yeah.
Oh, you just used these numbers, huh? Okay, if you did it, is it alright if we use the exact? You said it was 7.1?
You accidentally put 23.47 instead of 74. You put
Oh,
47
yeah.
instead of 74.
Oh, I did that,
So it
huh?
is 71, yeah.
Thank you for pointing that out. I was being a little dyslexic there. Not helpful. Sorry. That's why, right? Makes sense. So this was 7.1? Does it look reasonable if we go back up and look at that resultant, that I went left a bit and then went up so much? It does, doesn't it?
I don't get the left part.
I went left horizontally.
Yeah, but it looks like it's just straight up.
Well, if it was to scale, it would look more like we went more
okay.
left. Okay, I have 1 minute. J, don't let that scare you. I is just a vector, a unit vector in the x direction, and J is a unit vector in the y direction. I can't spell. How do I know that this is in the x direction? How do I know I is in the x direction? By looking at it. Because I have 1 in the x direction. Y direction. So I can rewrite this as 3 times 1 comma 0 minus 5 times what? 0 comma 1. And I could multiply that in and get negative 3 comma 0 plus 0 comma negative 5. And now what could I do? Add them? And we get what? Negative 3, 5. So this is just a fancy way of saying, taking the coefficients, negative 3 comma negative 5. That's all that is, okay? They use the IJ vectors in physics. They call it I hat, J hat. What? No. This is just a vector.
Yes, we did it. I'm here up like, where is it?
I don't know.
That's kind of where my mom is. Where do you need now?
We got a school record holder in here, Lauren Maresca.